Alright guys, thanks for joining me tonight. This is going to be our first video lesson, and then tomorrow we're going to be following up this video lesson with some activities that help us enhance what's going on. I know I covered this in class today, but this will be like a normal PowerPoint or a normal lecture. The notes will be in red. If you want to follow through and take the notes, you can pause the video and then go back and keep rewatching or go at your own pace. At the end, there are going to be some questions on the Google form, and you can answer those questions and submit it. It's due by 8 o'clock tomorrow morning. So, today's lesson, we're going to be covering the Bohr model of the atom. We're going to be introducing some of the basic energy levels that you covered in chemistry, and then we're going to be looking at how energy moves through the Bohr model. I'm sure I'm going to make some mistakes here as far as mouse cursor and whatnot, so bear with me. This is our first video. We'll make it work and see how it goes. Alright. Don't need to do that. We'll restart that later. Alright, so I'm going to move myself up here, so I'm going to be kind of minimized. Hopefully we can still see most of what's going on. Alright, so how can we analyze the energy levels of a hydrogen atom in the Bohr atom? Alright, so this is what we've covered in chemistry previously. How are electrons arranged outside the nucleus of an atom? Well, you knew from chemistry class that you had multiple energy levels, and 2 were in the first level, then 8, then 16, and I'm not even sure. That's not my expertise. But we are concerned with the idea that electrons are in different energy levels. So if we look here, electrons occupy energy levels outside the nucleus of an atom. For us, what we really care about is that each energy level has a specific amount of energy. So we call the first level there the ground state, and that's the lowest energy level that an electron can have. And then it could take the second, third, fourth energy levels, and so on. And if you look in your bottom right, there's a picture. And in the ground state, it has 0 joules of energy. And as it moves up, it's going to increase in energy. There we see the units of joules for energy, but we're actually going to use a different unit. As we can see here, the unit we're going to use is electron volts. So let me just explain a little bit about what we're looking at here. On the right side, we see the energy levels moving away from the nucleus. N equals 1 is the ground state, N equals 2 is the second energy level, and so on and so forth. On the left, we can see the same picture, and we can see the ground state is N equals 1. As we move up, we've got N equals 2, 3, 4, 5, 6, and then infinity, and we'll get to that later. Each level on the right side of that picture, you can see, is assigned a certain amount of energy. Negative 13.6 for the ground state here, negative 3.4, negative 1.51, negative 0.85, so on and so forth. This is a model that was described by Bohr, and it works specifically for the hydrogen atom. All right, we're going to look at how electrons can move between those energy levels, and that's what we're primarily concerned with here. Our goal here is to understand how electromagnetic radiation is created and absorbed by the atom. And so we're going to come to understand that as electrons move towards the nucleus, they lose energy. So let's say an electron was in the N equals 2 energy level and it moved to the N equals 1 energy level. It would have lost energy. And as the electron moves away from the nucleus, it gains energy. So the question we want to ask ourselves is, how does this satisfy the conservation of energy? We know that an electron, as it moves towards the nucleus, loses energy, but that energy can't be destroyed. That's the conservation of energy. So the energy is going to take the form of a photon of electromagnetic radiation. And so we're going to look at 2 mechanisms that work here with the energy loss or gain and how the photon results. The first we're going to look at is photon absorption. As an electron absorbs a photon's energy, it moves away from the nucleus to a higher energy level and gains energy. the equation, and this is in our reference table, we can say that the energy of the photon that is absorbed, the energy of the photon absorbed by the atom is equal to the initial energy of the electron minus the final energy of the electron. So the electron started in one energy level, it finished in another energy level, and we're going to look at the difference. So the photon energy must equal the difference in the energy of the electron. So let's look at a practice problem real quick. Uh-oh, my sizes are not correct. I'm going to zoom in here. Oh, got the wrong one. All right, see if I can fix this real quick. Nope, did it again. All right, I think I need to do a little more than that. Oh, I'm zooming in. Going the wrong way, guys. Sorry, maybe I can do this. Nope. Slow process. All right. All right, so quick practice problem. Oh, I see the problem. All right, ignore what's on the right side of your screen. That's not supposed to appear in the PowerPoint. If you were looking at it on the screen in class, you wouldn't see it. All right, an electron jumps from the ground state to the n equals 4 energy level in a hydrogen atom. What was the energy of the absorbed photon? So we know, if we look at that energy level diagram, that our electron started in the ground state at the lowest possible energy level. And now it's absorbing a photon as it moves to the n equals 4 energy level. So the initial energy was negative 13.6 electron volts. And then it finished with 0.85 electron volts. So if we take that and put it into our calculator, negative 13.6 minus negative 0.85, we get 12.75 electron volts. Some of you guys may be saying, why are we positive there? And I'm just going to ignore the negative sign of my answer, and I'm going to know that the positive answer means that we absorbed the photon because our electron moved to a higher energy level. Now, as we move up and absorb photons, we could go from n equals 1 to n equals 2, n equals 1 to n equals 3. We could go from n equals 2 to 4, 5, 6. We can do any number of different jumps. But there's a special jump that we call ionization. If an electron absorbs a certain amount of energy, it escapes all energy levels. It has become a positive ion. This is called ionization. The electron is now no longer in the atom. So we would have a positive ion in this case because we lost an electron from a neutral state. Practice problem. How much energy does an electron in the n equals 3 energy level need to be ionized? You can look at your energy level diagram there on the right and see that we started with negative 1.51 electron volts. To be ionized, we need to go from negative 1.51 to 0, energy initial minus energy final. So we would need exactly 1.51 electron volts to be ionized. At that point, our electron would no longer be in the atom. So that's photon absorption. The other mechanism that we're going to look at is called photon emission. That's the opposite of photon absorption. As an electron moves towards the nucleus to a lower energy level, it loses energy and emits a photon with the same energy that was lost. So it's the opposite, and now our electron started with a high amount of energy. It's moving down towards the ground state, and it's going to emit a photon. This is the primary mechanism whereby electromagnetic radiation is created. Quick practice problem, and then we're finished here for the day. How much energy does an emitted photon have if an electron drops from energy level 5 to energy level 3? So if you look at your diagram there on the right, the electron is starting with negative 0.54 electron volts. It's moving down to negative 1.51 electron volts. And so when we set up our equation, you can see it there in front of you, our electron has lost 0.97 electron volts. And by losing 0.97 electron volts, the photon is emitted with the exact same energy. All right, so just to review, guys, you can go back and watch this again. You could take the notes. The red ones are the things that I find to be more important. And then you can go to the Google form. There are a couple multiple choice questions that you need to answer and submit by tomorrow morning. And we're going to try to do this about once a week. All right? And I think the pre-made videos that I'm making will hopefully work better, and you get to see my face. Thanks a lot. Have a good night. Don't forget to do the questions.